Hi everybody, today is the seventh webinar of CV in cooperation with Onyx Solar. At the beginning, Ms. Christina will speak about Onyx Solar's Bipv project in Bursa in Turkey. She will discuss the project features. After that, I will continue the presentation. Hi Christina, Christina, we are hearing you.
Hi, thank you for inviting me to this webinar. I would like to make a presentation um, of one of the BIPV projects we have. So, uh, I don't know.
Maybe an internet interruption occurred. Sorry for that. We are waiting for Christina for some minutes. After that, we will continue.
Okay, can you hear me?
Okay, I think it's better to start. Christina will start her presentation after me. Thanks to Christina. Now we are going to speak about global market of BIPV. Global market of BIPV was estimated 14.4 billion USD in 2020 and will reach to 59.5 billion by 2028 with a rate of 20%. In this slide, we can see market of PV in Spain. The whole market is BAPV with 49 megawatt. Also, as we can see, installed capacity is improving from 2007 to 2015. Switzerland installed 313 megawatt in 2015, out of which 20 megawatt was of BIPV and the remaining of BAPV type. The associated investment value was €616 million in 2015. Starting 2010, the annual installation started to increase significantly. In France, the total installation in 2015 is €1.24 billion, which about 10% is BIPV and the rest is BAPV. As you see, three different feed-in tariff has been offered for BIPV for low size, medium size, and high size. In Belgium, the total investment in PV in 2015 is €150 million, which 10% of that is BAPV. Here we see BIPV market by region from 2015 to 2021. There is annual growth in Europe, USA, Japan, China, and other regions. Totally, it's an increasingly trend graph. In this slide, we can see continuous increase in BIPV installation in the world from 2014 to 2021. In another forecast, continuous growth of three types of BIPV roofing, walling, and glass from 2018 to 2026 have been shown. Here in this slide, the top three European countries in BIPV market are Netherlands, France, Germany. The compound The compound annual growth rate is the annualized average rate of revenue growth between two given years, assuming growth takes place at an exponentially compounded rate. Global building integrated photovoltaics market by region. Europe accounted for a major market share in 2020. Countries such as the UK, Italy, Spain, and France significantly contribute to regional growth. The European Commission supported directives in the form of financial incentives, such as subsidies and photovoltaic integration, are expected to further accelerate the regional market growth. In addition, Europe has been drastically reducing levelized cost of electricity of its solar installations, thus offering lucrative growth opportunities to the industry. Global building integrated photovoltaic market by application. The roof segment announced for a major share in the building integrated photovoltaic market in 2020, owing to the availability of a larger panel installation area for Bipv. Countries such as the US, the UK, Germany, and France are expected to witness increased demand for roof installation in the residential sector. In addition, growing deployment of energy storage systems is expected to facilitate demand for off-grid solar PV systems during the forecast period. Here is the BIPV market share by region. Main markets are in North America, Europe, and Asia Pacific. From 2020 to 2025, the highest growth rate in Asia Pacific, medium is in North America and Europe, and the lowest is others. Now in this slide, SWOT or SWOT analysis, S stands for strengths. BIPV has very good scope and it's shown a great potential to present itself as one of the promising applications toward the modern infrastructure. BIPV first and foremost strength would be easiness in the functioning process of converting light into electricity. Another major one is visual comfort with a pleasant look. It has a scope to accommodate itself in any style of building. This is due to development of flexible and transparent VIPV modules. Another strength is the cost-saving potential when compared to the traditional ones in terms of building material and labor costs. W stands for weakness. Like any other system, PAPD has also having few weaknesses. This include the lack of skilled workforce starting from academia to industry. This results in the complexity of the building designs as well as the overall system design. Another important one is the framework standard and policies for the better improvement in the BIPV product, material, etc. O stands for opportunities. The increased cost of the electrical utility price is one of the reasons that gave an opportunity for PV as well as BIPV. Another one is the measure related to emission reduction from the building sector, either by proceeding to completely green building measures or applying energy efficiency practices. Wide acceptance of the solar energy utilization and its diversified application will also help in looking for better opportunities in developed as well developing countries. T stands for streets. There exist few streets with the BIPV system. This includes how a technology supposes to be used, possibility of conflict between the construction uh, field and energy field professional, while farming standards, policies, etc. Establishing the common standards on a global level might be difficult, and this may lead to technology field. Downfall of the market might be possible with respect to feed-in tariff reduction. UAE has great potential for solar Bipv market with the all new development and available sunny window per day. There has been increasing demand for integrating solar panels into buildings in UAE to come up with innovative and self-generating building design. More architects and designers are getting familiar with this technology, and we are committed to reach out to building owners, architects, and investors to ensure their buildings are equipped with some notion of self-generation and more specifically BIPV. Here we briefly introduce several landmark solar BIPV projects completed in UAE to date. The Dubai frame is landmark project also fabricated by Onyx Solar. The frame is 115 meter tall and 105 meter wide, which is located in the Zabil Park in Dubai. The project with the integration in the facade is 100 to 1,200 square meter of amorphous silicon fiberglass, which is considered a large installation in the market. This picture belongs to the south elevation of United Arab Emirates University building located in Al Ain. The installed colorful solar BIPV module composed of 209 units were designed and installed by CAV Canada, an authorized partner of Onyx Solar in UAE. The project is being commissioned and more detail about the design and installation will be discussed during next session. Savvy Canada has been active in UAE market since 2019 as BIPV specialist in the market. Since then, we have completed several consultations and installations in the region, and the list goes on. For every type of building, regardless of the type or orientation, we have a BIPV solution. We offer turnkey solution when it comes solar BIPV from architectural design, electrical engineering, procurement, construction, monitoring, operation, and maintenance. Our advantages are as follows: have been involved in solar BIPV consultancy and design since 2017 in Canada and Middle East, composed of a unique and versatile team of experts with electrical, mechanical engineering, and architecture expertise. Offers in Toronto and Dubai. We are authorized sales and installation partner for Onyx Solar on its monitoring center for the surveillance of the performance of our installation. Another view of CV project in Al Ain, the BIPV integrated into building curtain wall facing south, no exposed wire glasses come in four colors with 30% transparency. Okay, photovoltaic gas integration. Here colors is to be provided at the rear side of BIPV unit. Color provided at the front could lead to significant drop of power output and it's not recommended by Onyx Solar. This slide tells us that produced power per square meter has inverse ratio with transparency. The lower transparency, the higher power production. This picture shows the facade system of Bipv in Dubai, which has been designed by Stantec International. Total area is 1,000 meters square. Electricity generated in 35 years is 490,000 kilowatt-hour, and total lighting points or operating 4 hours per day in 35 years is 963 lighting points. Okay, now we are waiting for Christina. I hope she can connect us for her presentation. She's from Onyx Solar sales team. Now our teams, Mr. Ehsan, our managing director, Mr. Mazia Ravan, the UAE project manager, Ms. Mariam Bolboli, VP Business Development, Mr. Ali Rafati, project manager, senior architect, and others are our team, our architect and electrical team. Thanks to our team and everybody who joined us today. I think we cannot have Christina today. I'm sorry for the problem happened. We will have her next webinar. So sorry. Thanks joining us. Oh, Christina is here. She connect us. Hi, Christina.
Hi, can you hear me?
Yes. We
Okay,
hear
perfect.
you. We hear
Perfect.
you. Okay, you can start.
Okay, great. Um, yes, I'm waiting for the presentation to appear in the screen. Okay. Well, today I would like to present one of the buildings that include our photovoltaic glass in the facade. That is a building located in Turkey, in the city of Bursa. Okay, next. Okay. Firstly, I would like to make just a quick presentation of Onyx Solar Energy. Onyx Solar is the world leading manufacturer of photovoltaic glass. This glass is like regular glass but with active properties, and it can be integrated in the building envelope, in canopies, skylight, facade, floor integrations, and generate electricity thanks to the sun. Well, our company started in 2009. Uh, we are a Spanish company. We have the factory located in Avila, in a small city in Spain. We also have offices in New York and Beijing. And so far, we have manufactured more than 350 projects worldwide. Next, please. Well, as commented, we have many projects executed so far, and these are some of the leading corporations that have already come with Onyx Solar. Here we have, for example, Apple in San Francisco store, Samsung, HP, Pfizer, McDonald's, or Coca-Cola are some of the clients that wanted to include Onyx PV glass in their project. Next, please. Uh, Here also you can see the architect and contractor that have worked with Onyx Solar. From Forster and Partner or some GMP, ACS, Skanska or Turner. These are some of the companies that we have worked with so far. Next, please. Well, as commented, we have many projects and we can supply the PV glass worldwide, from Australia to Kenya or Canada or Chile. For us, we can supply the PV glass to all the countries worldwide. This is just some example of some of the projects we have executed, for example, in Spain, in Kenya, in Egypt, Brazil. I mean, this is something we can do. We can supply the PV glass worldwide. Next, please. And now I would like to talk a little about the two photovoltaic technologies that we can manufacture. Firstly, we have the amorphous silicon. That is this is a technology that allows unobstructed views. So it's like regular glass, like with just a tinted color. We can offer different transparency degree from fully opaque to 20, 10, 20, and 30 degree. Here we are talking about an efficiency between 3 to 6%, depending on the transparency degree selected. And it shows a very good behavior in vertical applications, okay, with no direct sun radiation conditions. On the other hand, we also have other technology that is crystalline silicon. This is most popular, I think, the most popular PV technology. In this case, we use mono or crystalline or polycrystalline cells, but we laminate these cells in two layers of glass. So we can customize almost all the parameters of the PV glass, the size, the cell density, the transparency degree, the color. Here we are talking about a very high efficiency, very similar to the typical photovoltaic panels for rooftop applications. So we can achieve an efficiency up to 18%. Next, please. Our main advantage is that we can manufacture 100% customized solutions. This means that our PV glass can fit the design of the architect in each project. We can customize the size, the shape, the color, the configuration. We can add an air spacer. We can add any color, any coating. So this is what is our main advantage, because the client doesn't have to change the design to put Bipv. We can modify our designs to fit into the project. Next, please. Well, these are some of the solutions or the executed project we have done so far. Here you have many different options, from facade, skylight, in amorphous silicon or crystalline. Next, please. More solutions, balustrade, floor, round skylights. All these projects are included in our website. So if you have some interest in checking other projects, just please visit our website of Onyx Solar, and you can see all these projects. Next, please. Well, now I'm going to focus in this particular project, that is Bursagat headquarters building, that is located in the city of Bursa in Turkey. In this case, we supply the photovoltaic glass for the integration in the facade. Next, please. Well, the idea of the architect was to make like a combination of photovoltaic glass, like creating a puzzle in a double skin system. In this picture, you can see clearly the initial facade, that is the curtain wall, and the double skin that is composed by this framing system and the photovoltaic glass. Okay, the general contractor of this project is Samvital company. The architect were Tago Architects, and the client is Bursagat, that is the local gas company. Next, please. Now I would like to give you some technical data about the project. As commented, this is a photovoltaic double skin. The technology selected is amorphous silicon with a 20% transparency. It's a small project. It comes with 315 pieces of photovoltaic glass, and with the small size, it's 500 millimeters per 700 millimeters. This is a fully customized solution. The size and the configuration was selected by the client according to the design of the facade. This is a 4.1 kilowatt installation, and it generates more or less around 3,400 kilowatt hour per year. Regarding the configuration, it's a double laminated glass, and the building wanted to get the LEED Gold certifications. Note that including photovoltaic glass in the buildings gives points to get the LEED certification. Next, please. Well, this is another picture from outside. It is a really nice project from the outside. The total area is 120 square meters. As commented, this is a small one. And the electricity generated in 35 years, that is the lifespan considered for photovoltaic solutions, is around 100,000 kilowatt hour. We have made some conversions of these energy generations, so you can have an idea of, for example, how many lighting points will be operating per day during these 45 years. In this case, we will have 194 lighting points. We will also avoid the emissions, the CO2 emissions of 66 tons, and also we will save a total number of 58 barrels of oil per square meter. Next, please. Well, this is all about the project. If you have any further questions or you want to check other different projects, I invite you to visit our website where we have published all our executed projects so far. Thank you.
Well, thank you, Christina, for your presentation. That was very well. Thanks a lot. We will have you with us in other webinars. And thanks for our audience to joining us. If anyone have a question, please uh, connect us or make contact with us or email us. Have a good day. Thank
Bye.
you, Christina. Bye.
Bye.